Take a look at these three lines. Which one is the correct graph for the equation y equals 1/2 x minus 1? Right, so here's the line with a slope of 1/2 and a y-intercept of -1. Now in this lesson, we'll be focusing on graphs rather than equations. So for this graph here, when x equals -4, what does y equal? You could use the equation to figure this out, but try reading it directly from the graph instead. Precisely. So here's -4 on the x-axis, and so here's where x equals -4 on the line. What does y equal? Well, if we extend a line over to the y-axis, we can see that y equals -3. And you can double-check this answer with the equation. When x equals -4, sure enough, y equals -3. So graphs are useful because they let you see how x and y are related rather than trying to figure it out using an equation. So next, take a look at this graph. For each of these values for x, try approximating the corresponding value for y, and give your answer to at least one decimal place. Nicely done. So when x equals -3, it looks like y is halfway between 2 and 3, so it's approximately 2.5. When x equals 0, y is about 0.6, and when x equals 4, y is approximately -1.8. So now that you've gotten practice reading this graph, let's flip this around. So next, given these values for y, try finding the corresponding values for x. Again, you should give your answer to one decimal place. And let's quickly do the first one together. Y is equal to 3 over here. So what's the x value when y equals 3? It's pretty close to -4, and it looks like it's about -3.8. So try estimating the values of x where y equals 1 and -2. Nicely done. So when y equals 1, x is about -0.5. And when y equals -2, down here, x is approximately 4.3. Now so far we've been looking at graphs that are lines, but if you can read a graph like this, then there's nothing stopping you from reading a graph that's not a line or a nonlinear graph, like this one here. So try performing the exact same steps with this graph and approximate these values of x and y. Again, let's do the first one together. X is equal to -3.5 over here, and it looks like y is close to -3, and it's approximately -2.8. So try finding these remaining values of x and y. Excellent. So here are the answers you found. Next, let's look at another nonlinear graph. When x equals -3, 0, and 3 on this graph, what does y equal? Right, so when x equals -3, it looks like y is about 1.5. When x equals 0, y is approximately 3.7. And when x equals 3, y is once again about 1.5. Okay, let's look at a real-world example. Here's a graph showing how an Olympic runner performed in the 200-meter race. Here, the x-axis represents the time since the runner started the race, and the y-axis represents how far the runner has traveled. So according to this graph, the runner finished the race, having run all 200 meters, in 20 seconds. That's really fast. The world record is about 19.2 seconds. So according to this graph, how long did it take the runner to run the first 50 meters? What about the first 100 meters? And what about the first 150 meters? You can give all your answers to the nearest second. Great! So the runner completed the first 50 meters in about 7 seconds, the first 100 meters in about 11 seconds, and the first 150 meters in about 14 seconds. Next, see if you can figure out how long it took to run each interval of 50 meters. So for example, you already found that it took about 7 seconds to run the first 50 meters. But how long did it take to run the second 50 meters? So from 50 meters to 100 meters. What's this time interval here? And what about the third 50 meters, from 100 meters to 150, or the last 50 meters of the race? Again, you can round your answers to the nearest second. Excellent! So running from 50 meters to 100 meters took about 4 seconds, 100 to 150 took about 3 seconds, and 150 to 200 took about 6 seconds. So the 50-meter interval from 100 meters to 150 meters took the least amount of time. So, at which point during this race would you say the runner was moving the fastest? Brilliant! So from this graph, you can see that the runner started off slowly, then accelerated and was running the fastest at this point in the race, and then perhaps got a little tired because the runner slowed down near the end of the race. So you actually just answered a question in calculus, a higher branch of mathematics that looks at how graphs change. There's more algebra to study before you start a course in calculus, but you're well on your way. To get started, what's the y-intercept for the line described by this equation, y equals 1/2 x plus 2? Here's a coordinate plane to help you out if you need it, and click down here if you'd like to review. Nicely done. Here's the line for y equals 1/2 x plus 2, and as you found, its y-intercept is 2. Now another way to see that is to recognize that for a point to be on the y-axis, its x-coordinate is 0. So if we take this equation and plug in 0 for x, we can solve for the y-intercept, which is the value for y when x equals 0. 1/2 times 0 is 0, so that means y equals 2. And sure enough, that's the y-intercept for this equation. Next, let's look at this point over here, where the line crosses the x-axis. This is known as the line's x-intercept. So if you had to guess, what would you say is the x-intercept for this line? Right, it looks like the x-intercept is approximately -4. Let's see if we can prove that. Now for any point on the x-axis, the y-coordinate is 0. So let's take our equation and now we'll plug in 0 for y. That will tell us the x-intercept, the value of x when y equals 0. To solve for x here, we can subtract 2 from both sides. So the 2's over here cancel out and we now have -2 on the left. Next, we can multiply both sides by 2. So on the right, the 2 and the 1/2 cancel out. On the left, we have 2 times -2, which equals -4. So we did it. We just proved that this line has an x-intercept of -4. So in general, to find an equation's y-intercept, you can set x equal to 0 and then solve for y. And that's because every point on the y-axis has an x-coordinate of 0. And similarly, to find an equation's x-intercept, you can set y equal to 0 and then solve for x. And that's because every point on the x-axis has a y-coordinate of 0. Try using these facts to calculate the x and y-intercepts for this equation here, 3y minus 4x equals 6. Nicely done. So the x-intercept for this equation is -1.5, and the y-intercept is 2. Let's check that by drawing the graph. So here's the line for the equation 3y minus 4x equals 6. And sure enough, the x-intercept is -1.5, and the y-intercept is +2. Okay, here's your next challenge. Suppose a line has both a positive x-intercept and a positive y-intercept. Which of these values could be the slope of this line? Right, of these 5 values, only these 2 can be the slope because they're both negative. There are many lines you can draw that have both a positive x-intercept and a positive y-intercept. What do all these lines have in common? They all have negative slopes. Okay, last question. What are the x and y-intercepts of the line that passes through the points 7, 5 and 3, 9? If you get stuck, click down here.